Alright, in this video I'm going to give you a couple of examples of some strange electron configurations. And I'm just going to do two, and for the most part that's all you really, need to understand. So if we look at copper, so I'm going to start with copper. Copper's number 29 right here. So I'm just going to go ahead and write the electron configuration for that. So copper is 1s2, 2s2, 2p6, 3s2, 3p6, where am I next? 4s2, and 3d9. Okay? Now, if we look at this and you see the very end here, you see that the D is just one short of being full. So really what happens with copper is it is more stable with a half-filled S. Okay, so what it does is it, instead of being 4s2 3d9, it's actually 4s1 3d10. So let me just draw what it actually is. It's 1s2, 2s2, 2p6, 3s2, 3p6, and then it does 4s1 and 3d10. So it's got this nice full D sublevel and then the S half full, and it's just a little more stable that way. Now, another example of one where half-filled orbitals are a little bit better than full orbitals is chromium, for example. Oops, chromium. So chromium, if we look on the periodic table, is in that same column, but it's right here at 3d4. So let me write that one out. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d4. So again, if we look, we see this D. Remember, Ds can hold 10, but they would be half filled with 5. So essentially what it does is this electron goes in here, and it's a little bit more stable with two half-filled energy levels. So instead of this for chromium, we have 1s2, 2s2, 2p6, 3s2, 3p6, and then 4s1 and 3d5. Okay, so just keep in mind that chromium, copper are a little bit weird, and ones that are in that sort of 9 and 4 section can sometimes tend to have an electron configuration that is more stable with half-filled S and Ds than it is with full S's and partially filled Ds.